So today, we are going to talk about using visual design in support of functionality. So let's see here. Who am I? Real quick, I'm the manager of user experience at FileMaker. I actually studied industrial design, so I come from a background of cognitive science, human factors, and the physical world of tools and interfaces. And I also studied business to see how design could be more effective in a company. And I've been doing this for a while now at a lot of different companies in Silicon Valley, Netscape, Adobe, Intuit, Yahoo, eBay, and I've had my hand in a couple of startups along the way. So it's been a really interesting ride, and a lot of things have stayed the same and a lot of things have changed. As you saw in the keynote, when people hear the word design, they often think of it as the noun form, something artistic, decoration. And I really want that thinking to shift to the verb form, which is to serve. It's to design, it's a process, it's a way of thinking. It's about facilitating what your users are doing. So I hear this over and over again from developers, which is, I don't have the time for design, I don't have the budget for design. And what that says to me is that design is optional or an afterthought, as opposed to being integral to the process that you go through when you're putting together a solution. And the ROI of integrated design has basically been proven in a number of industries. And so my hope is that you can take just a couple of pieces of design thinking with you and start applying them to your whole process. The other thing I hear a lot is, well, I don't have the skill to design, I don't know where to start, so I'm not gonna bother. And I say start somewhere, even somewhere really small. Even if you take one thing away today, use that. And gradually, design will become more a part of what you do. So we're gonna talk about today, we're gonna touch a number of these subjects. We're gonna talk a bit about the science behind what these decisions are that you're making. We're going to look at some graphic design fundamentals because they really built a lot of the layout fundamentals. We're going to look at some of FileMaker Pro 12's design surface tools, and we're going to look at these things through a number of case studies. Okay, so some background. These are going to be some really simple examples, right? We learned as kids that we see things upside down, right? Our eyes, the way our eyes work is that they see something and they flip-flop it. That's your brain doing that. We have two eyes. They each see slightly different things. Your brain actually puts those things together to form a picture. We have an ocular nerve that attaches our eyeballs to our brains. So we actually have these two blind spots in our field of vision. We don't notice them day in and day out. Our brain is filling in the information, but they're there. So roughly speaking, the world could look like this, but our brain is putting it together to form a real picture. There's also, if you've studied child development, you know that we gradually learn to perceive depth, and that comes through both your eyes maturing, but also knowing what the cues are that you're seeing to understand what it is and what's going to happen if you go over that visual cliff or actual cliff. There's a really interesting study of what people see if they were born blind and then gained vision. And one of the most interesting examples is a woman who gained vision for the first time in her life and was told that this was a tree, and she learned what a tree looked like, but what she called it was the tree with lights in it. Because what she didn't realize was that she was actually seeing through the tree to the background behind. So again, your brain, you're learning cues along the way to understand the world around you. Another example of this is an optical illusion. Right? Do you see the faces or do you see the vase? Now, our brain is drawing on a number of cues there. It's a solid-void relationship. Which is the solid and which is the void? Which is the negative space? And it's figuring that out by the edges. It's also figuring that out by the density. But this is actually missing some cues that give your brain enough information to know which one it's supposed to see most prominently. Right? So that's our brain. Our brains are constantly working to understand and resolve the world that we're seeing and to know what to do with it. So that's a big part of what these decisions that we're making have to do with layout design. So our brains, in order to process, have a number of techniques that we're going to talk about, and these are all going to apply to some of these choices. And some of the key ones are about scanning and finding patterns, interpolating and ignoring, and noticing outliers. So we're going to look at a couple of these. So scanning and finding patterns. So in at least the Roman languages, we know that we read from top to bottom, left to right. And so when you watch eye tracking studies, you see the eye starts at the top left, and that's really heavy there. And it'll move down, it'll move across. What I find really interesting with these is you see the big blocks of ads that are supposed to be eye-catching? You see how the eyes, there's barely any movement happening in those blocks of color. And that has to do with the fact that your eye is actually bouncing off the edges. It's ignoring that. But you notice the example of Facebook there on the bottom. And the eye actually passes through all of those ads because the density is similar to the content. So we're mechanically programmed based on how we learn to read, but we're also doing things that we don't quite consciously understand because of the changes in these layouts. Interpolating. I love this example. The phenomenal power of the human mind, according to a research at Cambridge University, it doesn't matter what order the letters in a word are, that I'm reading exactly what you're seeing, right? It's phenomenal to me that we can, English speakers, can read this very quickly because we're honing in on cues that we're not even realizing. 95% of you will read this incorrectly the first time. A bird in the bush, right? It's not just at a word-by-word level, but it's also phrasing. Like, we learn to pick up patterns, and that's how we're interpreting. And so our heads don't explode every day. We are programmed from the very beginning of time to notice outliers. We can't have our brains focusing on every detail of everything going on because there's a really good chance something's going to eat you. Right? So our brains are keeping us safe, and so they're focusing on the things that really need attention versus the things that don't. So I'm telling you these things because I'm hoping that you'll remember some of them that will help support some of the decisions you'll start to make. So let's take a look at an example of this. So when you have a set of fields, this is a very regular pattern, regular size, regular spacing, regular type. There's an outlier. If you're red-green colorblind, it's not going to be as strong, but there's going to be a change. There's another outlier. I actually think that this is an interesting one because you might not have noticed it at first because you were probably scanning down the left side. But it's there, and you will notice it. Your brain will pick up on it. So when we take a look at layouts like this, which I see many of, and I know that this happens to layouts over time because they'll be built and people will add things and maybe they aren't sure what font was originally used or maybe they just don't have time to, see and change it. But when you're looking at something like this, your brain is trying to find patterns. It's trying to understand what is regular and what is not, what is important for it to look at. And it's hard to tell from this. So when I did a count, there were 5 different action zones, like the primary actions that people would take. There are 5 action and nav zones in this. There are 14 different field heights, and there are 27 different type treatments. Now, this might be an exaggerated example, but even you go beyond a handful of differences in a layout, and your brain is starting to work hard. It's starting to say, what am I supposed to be looking at, and what is supposed to be important to me? Graphic design provides a number of techniques to help deal with these things. It helps keep your brain processing to a minimum so that you know what to look at and what's important. So some of these techniques are things like modules and grids, repetition, scan line, density, color range. It kind of boils down to regular versus irregular. So let's take a look. Irregular, regular. Now I love this example because as type and books were developed over time, it used to be that we didn't have periods, we didn't have punctuation, we didn't have paragraphs. And over time, it wasn't enough that this information was being recorded. It needed to be recorded in a way that more of its meaning would be conveyed. And so the end of a thought with a period, the start of a new topic with a paragraph. It used to be that initials, these colorful initials were used. And this example shows some smaller initials and some bigger initials, right? All of these things start to bring meaning to how are you supposed to interpret the information on this page. Modules and grids are used not just in page layout. They're used in so many ways in our lives. And if you've ever gone to a city, I think the difference between Barcelona and New York, it's great, but they're each based on a module. So once you know what the modular unit is that the city's based upon, and you start to understand, well then, what are the naming conventions of the streets, you can pretty much find your way around any city. So the same thing happens in just the way type is developed, right? Fonts and type construction. It's not willy-nilly. It is actually based on pure shapes that we're comfortable with, and there's a rhythm to it. The rhythm gives it meaning. This foundation of the actual character, the letter forms, I think in calligraphy is really interesting. I mean, it's physically based on the nib of the pen, right, of the quill, right? And so when you're constructing in calligraphy, you actually set up your units that are going to create the shape of an O versus an L versus an M. That construction actually then gives the framework for creating lines of type. And I love this example because here you have just a chunk of type. But can you see where maybe the thought changed? There's a nice red swipe there. It's really subtle. But I mean, these are cues that tell you how to interpret that. Same thing physical when you're setting print type. I mean, you have actual characters, and those are based on how well you could form the lead, but also how much ink was going to be held on that character and then applied to the paper so that you could still read it. A really physical meaning behind a lot of these choices. And then where is that going to go and what's the shape of the paper and how much can you fit in a space. It's constructed based on knowing how big those characters are going to be, how much ink is going to be absorbed and maybe spread through the paper, and then how many characters could be read before you started to fall through the paragraphs with your eyes. And then you have things like the golden mean, right? Thousands of years, mathematicians and scientists have been just fascinated by this relationship. And they use it to base buildings and pages. It's a really interesting relationship, and people believe it's more aesthetically pleasing. Always a place to start. I just think it's really interesting how we as humans find these ways to give pattern to the world. The Apple logo is based on the golden mean. So when we get into the world of digital type, we start to lose that physicality. And I mean, we used to have pixels, and now when we're into points where it's resolution independent, we're still craving this need for a modular unit, right? Because now we're not sure where is this type going to be read, and how visible, how legible is it going to be? Is it going to be on a screen, big screen? Is it going to be on a tiny device? Is it going to be in bright sunlight? Is it going to be in a dark office? It's harder to know. And so one of the ways that we can find a modular unit in type in independent resolution is we can take one of these forms, but one of the things that these letters are built on is known as the M. And it's an overall proportion given the letter's width and height with respect to the point size. And one of the things that I want you to understand about the foundation of the theme system and our change to resolution independence is that when we constructed the themes and chose the type sizes, we did it with a very specific idea in mind. Everything about the themes is actually based on that modular proportion system. And part of what that's giving you is a way to provide regularity without having to think about it. So if you're using the defaults, if you're using drag out the field and it sits there, that is a modular unit that already has built-in M proportions and relationships that you won't have to think about. So I'm not sure how many people know that, but each theme is built that way, along with the different, if you put it through the layout wizard and build reports or something that way, the defaults are actually set up with the same set of construction. So I'm just going to quickly jump over to this, which is one of the starter solutions, just to illustrate that. So if you can see the lines here, I'm going to use the dynamic guides. Can you see the dynamic guides on screen? Okay. I mean, it's just, you don't have to question some of the units in this. If you start to bring it out, it's just one less thing you have to think about. From there, we say there's best practice of actually building layouts based on a column system. We're going to go into this much deeper. But just the 12-point and the default grid system in the system is actually work together. They complement each other. And you could have a 2 or 3 or 5 or 4, a 2 by 3. So this is a 5-column grid, and this then takes 1 3-column 1. This takes 2 and then 3.